Mr. Chairman, ladies and gentlemen, good morning. It's very good pleasure indeed for me to be able to attend this meeting. Today I would like to present my paper, the single detection method in OSN based on DistilBERT and Double-SN-LSTM for text analysis. In the first part of the report, let's think about 3 questions. First of all, initially, what is a symbol attack? A symbol attack was originally used to describe a form of attack that acts on a P2P network. For example, when an attacker uses a single node in a P2P network to push multiple identities, weaken network redundancy, reduce network robustness, and interfere with normal activities. Secondly, why symbol attack can be implemented in OSN. OSN services are generally implemented as open access systems. Open access systems try to provide their services to as much users as possible without verifying the identities of users during registration. OSNs are open access systems due to a variety of reasons. Users may not be comfortable sharing sensitive information, like social security number, through third-party services. Also, keeping such sensitive information about the user is dangerous and prone to information leakage. Since many security mechanisms are based on the assumption of real identity, an open access system doesn't follow these assumptions. Symbol attacks are made possible on OSN services. And finally, what is a symbol attack in OSN? In a symbol attack, a malicious entity tries to multiple fake identities, which gets registered for services of OSN. OSN service considers these symbol identities as real identities, even though they are in control of a single malicious user. These symbol nodes are then used to influence tasks, which require collaboration from a multitude of nodes in the network. Examples of such tasks can be voting scheme, collaborating spam detection, etc. Then I will introduce our contribution for 3 aspects. First of all, we propose an end-to-end classification and detection model based on the content posted by users. This method avoids the highly user-friendly features of carefully forged symbols, which not only improves the classification accuracy, but also reduces unnecessary expenses. In addition, the proposed analysis model uses bidirectional encoder representations from transformers, which is BERT model, that have outstanding performance in natural language processing tasks for text analysis. At the same time, we consider the timeliness of BERT and it compares and chose its optimized distilled version of BERT, called the DistilBERT pro-training model. Moreover, to fully consider time features, the time series association between each text content is extracted through the 2-layer long short-term memory with self-normalization RNN model, which was proven to be effective. Last but not least, based on the tweets regarding the 2020 US presidential election, we contrast the dataset with real accounts and symbol text. This dataset contains 222,802 tweets related to Biden or Trump during the election of the US president from October 15, 2020 to November 3, 2020, in which there are 949 real accounts and 987 symbols. The dataset has now been published in the GitHub open source warehouse, and it can be used by relevant researchers for further analysis and research. And then, I will introduce our dataset construction method in detail. The baseline dataset in this article was derived from Kaggl's public dataset. The first one is the US election 2020 trace dataset, which provides a total of 1,727,003 tweets with Donald Trump and Joe Biden as relevant hashtag during the US general election from October 15, 2020 to November 3, 2020. The second dataset is political tweets with Twitter bots dataset, which provides a total of 198,550 political relative tweets issued by robots during the US general election from October 19, 2020 to November 3, 2020. And with the two datasets, to contrast a positive sample, we manually selected 987 symbols from the public dataset tree. And to contrast a negative sample, considering the public dataset 1 must include robots and symbols, we firstly deleted all the data of users whose username matched the username of robots, and then deleted all the data of users who mentioned robots in the published tweets. Furthermore, the number of tweets published in this time period needed to exceed 10 to meet the experiment requirements. Finally, a total of 949 negative samples was obtained by manual scaling. When it comes to the manual check, we consider the static information such as personal information, including the number of friends, the number of likes, the number of followed, profile, etc. Whether the content of tweets is abnormal, tweet frequency and content repetition, whether it has been officially suspended, whether it is marked as a robot account in the known blacklist. The judgment provided by other plugins such as BotSite and BotSentinel is used as a reference. The following figures shows many details of our dataset. Next, I will focus on our system design. Our system has 3 layers in total. The base layer is data pre-processing, and the second layer is samples embedding. The last is classification layer. As a data pre-processing layer, we need to determine the maximum number of tweets of each user and the maximum length of each tweet. Then we need to normalize each tweet, that is to replace all links in the tweets with a unified form of HTTP ://u. And then we need to input them into the tokenizer of DistilBERT for word segmentation and indexing. And finally, we need to build it up to the maximum sentence length with 0. And thus, it is necessary to use mask to distinguish between the field part and the data part. At the sentence embedding layer, we need to convert a fixed length sentences expressed in the form of a word index value into a vector with a fixed dimension through DistilBERT. The DistilBERT model uses knowledge distillation based on BERT model to achieve a faster, lighter, and very simple model to the original model. Knowledge distillation can be understood as a method that enables a lightweight and compact student model to a more massive and excellent teacher model. When BERT and DistilBERT are trained in the teacher-student structure, the DistilBERT simulates the output distribution of BERT, and DistilBERT can learn most of the experiences of the BERT model. Experiments show that the number of parameters of DistilBERT was 30% less than that of the BERT model, but it still retained 97% of the performance. And the embedded vector must well understand and extract the semantic features of the text. As the input of the classifier model helps the classifier model achieve better classification results. Then we choose the first particle CRS output by the model as the input of the classification layer. This is because the CRS as the starting tag of the text doesn't correspond to any word in the text. Finally, at the sentence embedding layer, we need to use a bio-LSTM model to extract the terminal association between each text content. The output of the last LSTM neuron in the network is sequentially input to the job-like layer, the fully connected layer, and the neuron whose activation function is sigmoid to output the classification result. At the end of the report, I will show you our comprehensive experimental results. For the selection of classifier, we choose common RNN models for comparative experiments, including simple RNN, GRU, LSTM, BI-LSTM, double-LSTM, and the double-SN-LSTM. And the evaluation indicator of the classifier includes the confusion matrix, false alarm rate, precision, recall rate, occurrence rate, and the air under curves. After 70 epochs, the indicators of each classifier stabilize. The value of each evaluation index on the test set is shown in the Table 1. From the experimental results of the sentence embedding through DistilBERT, the above RNN models learn the semantic features and mutual relations of sentences very well, and they give correct judgments. The loss curve of each classifier on the training set and validation set is shown. We can see the double-SN-LSTM performs best. Following figures show the evaluation index curves of each classifier on the training set, and that is on the validation set. It should be noticed that the experiment used a 5-fold cross-validation method to divide the dataset, and it took the average of 5 results obtained in a run as the output result of the epoch. Finally, I will make a conclusion. In this article, we proposed an end-to-end model based only on text content analysis to detect symbols in OSN. That is, to detect such accounts only from the behavior level. Static account information and social network relationships delivery contrast by attacker will also affect the detection results of the method. And thus, it can better detect the symbol accounts that are carefully forged by the attacker. Moreover, we contrast a new dataset that is more suitable for the text analysis for other scholarships to use. And we use DistilBERT to extract the semantic features of the text for embedding, which can better reflect the semantic features of the text compared to other embedding methods, such as word-to-vec and BLAP. After comparing experiments with various recurrent neural network models, we decided to use the double-SN-LSTM as the classifier. From the perspective of evaluation indicators, our model and methods have a high detection rate for symbols. Finally, our future work will focus on how to integrate the structure-based features with the content-based features to achieve a more in-depth and comprehensive detection to deal with the attackers' constantly changing bypass strategies. Thanks for your time and attention.